I'm just going to do it live again so I don't have to edit, just to get something up and kind of cover the progress with the latest project. So I think last I left off kind of was showing this mini split, which I'm repurposing to be both the AC in my projects room, which will have a door and the AC's in there, and also be heating the water ultimately. But I think for right now, I'm not going to hook up the hot gas loop to the water heater. Leave that one up and running the way it is, just to get the cooling going. But I do need to get my expansion valve stepper motors working so I can even get that far. So I think I already showed this last time. This is the actual original rotary compressor I had in my homemade water heater. I took it out when I bought another little $40, used window shaker and put that compressor in. It's a little smaller actually for my water heater heat pump, and it's working. I know this compressor works good, so it's in here now. It's a split circuit. The top half I made into an evaporator, and the bottom half's into the condenser, which will be in series all the time. I'm going to have the hot gas go to the heat exchanger first and then come out to the condenser. And I think to stop adding heat to the water heater on a high limit, all I have to do is stop the pump, and it should just be fine. And then this, I think I'll have a temperature actuation for the outdoor fan, and it'll run. I have a little inverter board here for the fan. So this should work. So hot gas comes in here, and it goes through the circuits here, comes out all liquid. And I got two expansion valves, one which is closed most of the time. When I'm trying to cool the inside, it won't flow here, and then it's going to just use this expansion valve, which goes to the 1/4 inch flare net. It's going to go to the high wall. It's right up there. Got my sensors kind of hooked up for the coil. That'll have to go to my EXV control board I'm making. So that'll be the normal mode. But when winter comes, the water heater runs way more, and it would freeze me out in this room if it was refrigerating this room. So that's when this valve will close. It'll just close, and then it'll start modulating this one to use. This top half will be the outdoor evaporator heat pump mode, in the winter. So I think that's going to be pretty cool, actually. So the thing I need to do is make something to control these. I've already got a cutaway expansion valve I've showed in some of my videos, and whenever I'm kind of running in a stepper motor driver, I can wind that open and closed. And for a while, I was just taking one of my boards already made, microprocessor, and I kind of reprogrammed it so I could kind of open and close the valve here. And I just had one of these stepper motor driver boards stuck on the breadboard. I had it all working, and then I made this board here that has two stepper motor drivers because I have two expansion valves, and it works. But this board's been kind of acting up on me now. So some reason some of the logic outputs go high when they're supposed to be low, and weird stuff. But as I said, I repurposed this board for my other project, so I'm making another board, which is where I'm at now. So over this last week, I kind of had to relearn how to use my small little CNC lathe that I learned how to use months ago, and then sat dormant for a couple months. So I of course ruined some boards. Had the wider bit in there, kind of ate too much. So finally the secret was going back down to the 90-degree bit and doing triple pass, and then I started getting some nice cuts again. And when using flux, this is powered up right now. So here's the processor. So right now I just have the processor dropped in, but the program is for the other thing. So the input, it's not, oops, I just spazzed it from pushing buttons. But it's just going through because it isn't programmed for this board and the inputs. So it's got a bunch of floating inputs. But it shows that my LCD's working, and the 5 volts, everything's connected good. So I just have to now write a program for that. Basically the other program I had, but just change the inputs and outputs. This is the output that's going to go from 6-pin. That's going to go from here to here. It's going to pass through the 12 volts, 5 volts ground, and then the two inputs, and then there's a logical high-low that switches the direction, the processor. This is cool. I didn't think of doing this before, but using this software here, the easy EDA. You lay out your components first, and then you convert it over to your PCB board. What I've been doing this time is I'm using single-sided boards, and as long as I can get almost everything to map to the bottom, and I make all my connections on the bottom, that way I can solder it, and then I just make manual jumpers. So I just had like 1, 2, 3, 4, 5 on this one, and I think only had 3 on this board here, which is this little. So I could do single-sided cheap boards. So but yeah, I didn't think about this time that I could just print this out. So it's kind of cool, as I can kind of see, now I can see here, and I'm going to be able to probably write on paper, but now I can look at this when I'm doing my programming and be like, oh yeah, my temperature for my coil, my outdoor coil, is going to be on input port, A4, and my coil temperature will be, the other one will be the indoor coil, A3, my ambient temperature will be that. Actually, it's not going to be ambient, it's supposed to be something else now. I'm live. In a minute. Priority. Okay, go.
It's your daughter's birthday.
All right. Her birthday could wait.
That video can wait.
No, it's live.
Okay, Jessica, just go.
For us, so rudely interrupted there. Where was I? That's why I'm building this room, because it's going to have a freaking door right here. Door. Because when I was sitting here, every time someone opened the garage door over there, they would just... I need my own world. You need your own nerd world. I can play some videos in the background, stuff like that, but you can't have conversations with people and do any of this. Especially when it comes to the coding and stuff. You will just lose where you're at. So, anyway. Yeah, so, ambient. And I also did put a couple spares, and I just didn't. There's nothing soldering, but I have a bunch of spare spots to put inputs or outputs. It doesn't look like anybody's texting right now. So this is like these 3 spots are like right here, 1, 2, 3 inputs. And I wrote them down here properly. Yeah, suction, and then the 2 coils, indoor and outdoor. And I'll just have to map it all accordingly. High pressure switch, I did incorporate that. I have to just drop a ribbon cable connector on there. And then your LCD, the EXV 1 and 2 step pulses out, and then the direction. So the direction goes to both at the same time, because I'm only going to drive one at a time, and all I have to do is give the command to pulses to one or pulses the other, And so I can pretty easily, which I've already done, use one microprocessor to run 2 expansion valves. Power LCD, so switches. So this is pretty cool. I kind of like... Yeah, I gotta go do that in a few minutes there, Tim. But I just got home, so I mean, they can wait a few minutes. It's not even that late, it's 5:40. But this is pretty cool, laying this out, and this, like, I don't have to show the connections. You just put the net connections here, they call it. You just label it. So this T ambient is the same as T ambient here. And T coil OD, they just map there. EXV1, 2, EXV1, 2. And actually, these are all, this means 3 spots. So T ambient here, here, and here all will network together when it makes this, when you do the routing. And the reason I'm doing that is actually a little trick to use less inputs is your thermistors work, they're 10K, thermistors, and then it has a 10K. So if that was 10K at 77 degrees, and this fixed resistors, the 3 right here, are 10K, you're going to get 2.5 volts split from the 5 volts, when you're at 77 degrees. An 8-bit count, that's going to be about 127 for a decimal value. And you work with that, and I already figured out, this equation, which I moved it down here. That's my equation. It works within a degree or so for converting that freaking 10K non-linear slopes, But what I do is, if I push the button's going to fully short this to 5 volts. The likelihood of it ever going anywhere near 5 volts with the thermistor and voltage divider is like nothing, and like it just isn't going to happen. So you have a certain range of your analog, measurement that you're never going to use reading temperature. So it's going to read temperature by default, but also within the subroutines, it looks to see if I have exceed a certain count. When I hit 5 volts from pushing the button, it's going to know I pushed a button, and I'm using the same input that is thermistor inputs. So 3 inputs for 3 different thermistors is going to be the same 3 port inputs on the processor for reading the 3 buttons, the 3 push buttons. Which the push buttons are only going to be used mostly when I'm just doing my troubleshooting to design it, and after that, once it's in there, it probably won't, unless I make a menu, which I probably will, to go in there and like manually open and close valves. So, and when this is all said and done, who knows, I might just take this same thing and build other boards and just have them maybe run off a battery pack or something, so I can like go up to these stepper motor EXVs and open and close them manually. Be kind of cool. So that's the idea with that. I don't know if I was holding the camera close enough for that, but that's how that works. So 0 volts is 0 counts, 8-bit value, and then 5 volts is 255. So I could just put in there, if it's higher than 220, then it knows it's a button press, and you're just polling the inputs for temperature, and then as a button press. Button presses, depending on where you're at in the subroutine, will do different things. So there's the processor. Still using these little ones. I haven't even bothered using the bigger, more powerful ones yet, but these $2 ones work pretty freaking good for making a bunch of stuff like that. So like I said, it's jumping around because it's got floating inputs, because it's this program in here is from that for all those inputs, and I just stuck it in here just to see that it booted up and the LCD was working. But yep, so there's how that comes out. It goes from this to this, and then I take it in this other software and just plot all the layers for the CNC. So I thought I was going to forget how to do it, but it actually came back to me. A couple ruined boards, like I said, until I got the isolation routing done nicely. So I'm probably going to put these boards in that unit, I guess. Or I could put it up in here, but there's just not that much room up in here. So probably out there. And then these two, all I have to do is make an extension. So this, I might actually disconnect the suction one here and just read. I think I'm going to read one suction line out at the outdoor unit. Common suction, probably have to do it right here. So it's from either coil and/or coil, outdoor coil, whichever one's running. And then I'll just need one thermistor on a couple rows in on this evaporator. You could do it, probably go right here or so. And that gives you your inlet coil temperature, and then there's your outlet, and just kind of make it chase about 8 degrees superheat, 10 degrees superheat, and modulate the valve. Do some repeats, in the subroutines, and just look at the error, look what it's supposed to be, and just adjust. And it shouldn't be that hard, I don't think. So I originally mounted 2 thermistors in here, but I'm probably just going to not going to use the suction one I labeled. I'll probably just use the coil one. Go out there, extend that outside. I got to bring power in to run the motor. And I'll probably just, I might hook a regular thermostat in here, and I think I'm just going to use a voltage divider set up just to step the commands for that motor, and probably won't use any feedback for it. Even though I could build a controller for it and look for the tach signal to know if the motor's running, but I don't think there's any point. If it ain't working, I'll just know it's broke. So probably use a regular thermostat in here, somewhere over here. You can go up the wall or something, and then have it, I might probably just mount the thermostat right there. Right there, that'll work. Wi-Fi 1 or something, and just have it do different steps for the fan, maybe, depending on staged cooling. And fan only, and then eventually, when it's all integrated with the water heater to heat the water, I'll probably have to have that thermostat basically just turn on that unit and tell the fan to go to high in here until wintertime, and then it's going to go to the outdoor unit. So we'll see how that goes. I think I'm going to wait till as summer's ending to to integrate it with the water heater. So I think I'm just gonna leave that heat pump that's hooked up to for the rest of the summer and just try to get this thing going just for the indoor section, just to cool. Because right now, I don't know if you guys got to notice, but to stay tolerable in this Arizona desert, my Frederick Carrier bastard high wall's right there with the towel. So this no shit, man. This fan's like capturing that air and blowing it through this hole. It's not perfect, but you know, looks like it says 70 or something, I think. Blowing in here, so it's tolerable, but it's not crisp. It'll be crisp. So let's see. Yeah, it is Shiva. Acid. That was a 16F, and that is a 16F 690. But do you have like binoculars for eyes, or just seem familiar? What? And I'm looking at the text before I go. What did you use for the side blowing heat pump project? Oh, the thing outside? No, that was just a regular scroll, gonna be a conventional heat pump with the standard TXV that's already in my R410 upstairs unit. So that project can continue this winter too, since I found out that there was nothing wrong with it, but I might simplify the controller a little bit. I don't know, but not to make it overbuilt in case anything happens. Although I built a whole bunch of those boards, so I had backup, but once I was practicing on my CNC. I've realized what happened, why it shorted, blew the VFD's rectifier, but was that plasma arc when my solder trace popped charging up the capacitors, you know. Just like most like small ECM motors usually have a capacitor about the size of this, maybe a little bigger, but these are pretty big ones, 220 microfarad, two of them. Yeah, when I powered this DC from the VFD to this through a little circuit board trace I made, that trace is so thin that it popped like a fuse. It was like this far from metal off the standoff. The popping made it a plasma, and then DC current just went right through that, avalanched in infinite current or whatever it could flow, you know, limited by the source and the wiring. And that's why I had that huge explosion inside there. But this part is good. Obviously, there was no short in here. It was just the fact that when I made my board, these two big fat wires for the DC bus, 230 volts, go through it, it just popped like a fuse. That's all. I just need to either make it a heavier duty connection, because, you know, there's not that many capacitors on here. I can't let it surge when it charges every once in a while. Or I need to do the current limiting resistor trick with a delay and then close a relay, which is what the big inverter boards all do. They take a couple seconds to get the capacitors off of 0 volts and then close the relay, you know, once it's kind of charged up a few seconds. So that's the idea. So, yeah, so got the old printer that I've had forever with refillable toner in there working, so I'm able to start printing stuff up right out here willy-nilly. That printer's not working all that bad for being like 20 years old. Actually, I think I got that printer when I was living in Payson, so I think that might be a late 1990s printer. Obviously, it's obsolete, but it still works. And print out stuff. Every time I work on a new project, I could just print out a new bare sheet and then just put notes around what's what. Now that I thought of printing this out, I can be like, okay, it printed right out from my, you know, design, and I labeled it. The only thing I got to change is the ambient is actually the suction. So I just need to scribble this out on here, so I remember. And then in this Pick Basic Pro I use, it's what I'm using for the microprocessors. It's just what I learned on and still use. I'll just, you know, define that as that, and once it's defined, then I'll just be working with, you know, ST for suction temp or something like that, and, you know, C1, C2, or coil 1, coil 2, whatever, or coil indoor, coil outdoor, whatever, and just got to get these switched to the right ones, but everything being the same, it should work. So I did realize that when I put this together, these are two different expansion valves. The one that was in here, and then I took these out of that 4-port carrier and stuck one in here. Well, it goes on and twists and locks. I really like them better than the other one, but I realized that they're not the So this one just snaps on. That was already in that unit, and this one's the twist lock on, like that is, which I've been testing. So these are six. That's a 6-wire. I made it work as a 4-wire. This one here's a 5-wire, and it didn't want to work. I was like, crap. But then I realized I could just lift that 5th wire to 12 volts, and I plugged it in, and it worked. So.
Ashton said Desert Rose isn't Desert Rose anymore.
Okay.
Oh, what are you doing?
Live. I'm coming up. Finish wrapping it up. So anyway, I think they'll both work without having to resolder anything or whatever. So anyway, let me make sure everything's turned off here. It's so rudely interrupted, but that is the deal. Anyway, catch you later. Don't forget to like and subscribe and share all the normal stuff. I'll catch you guys later.